Hi again. Okay, so here's number 8. Sorry, in my last email, I think I said that I was using the alternating series for number 8. I meant to write number 9, so I think you probably figured that out from the video that I sent you, which was number 9. So here's number 8. And so with number 8, here's my confusion on this one, is just that this part of it suggests to me that this should be the alternating series test because of the +1, -1, +1, -1 thing. I think it just almost has to be. And so if you go with that with this one, and you've got your two conditions that you're trying to satisfy, then what happens is that the first condition would say that the limit of our function sine n over n squared would have to equal 0 as n approaches infinity. And actually, I don't think it does. Actually, no, it does. Yes, that one does. Sine x over x approaches 0, so sine x over x squared should also approach 0. Yeah, it does. So yes, it does do that. Here's the problem. The second part of it is that this has to be a decreasing sequence, right? So Bn, which is the sine n over n squared, has to be a decreasing sequence, okay? Or series, I guess. And it's not, even if we make it absolute value of sine n to get rid of all the negatives, it's not going to be a decreasing series because some of, that's a tough one because sine oscillates. See, that's where I'm confused on this one, because I think that it's this condition that we break, because sine x over x and sine x over x squared are divergent series. So if those are divergent, then I think the alternating, it doesn't work that way either though, does it? So going back to what, okay, so forget about the divergent, what I was saying here. I don't think that comes into it because we're not doing the comparison test. We are just looking at whether or not this series is decreasing. How can we tell? Like when we're dividing by n squared, it should be decreasing. But if we're going from negatives to positives, like we do with the sine curve, right, then like the sine is increasing. If we're going from a negative to a positive value, we would have to be increasing at that point. And so I think that it's that part that is not correct. And so my conclusion there would be that it's a divergent series based on the fact that we can't meet both conditions. Now this one's tricky because I think that you can prove that it's convergent if you can meet those conditions. I'm not sure that not meeting them proves that it's divergent. You might have more information on that. But I think we're going in the right direction, but then we might have to do more to test on this one. So I'll have to give that one some more thought and see if I can come up with anything more on that one.